Hello friends, today we are discuss ideal current source and practical current source. First we can see ideal current source. Now this is the symbolic representation of ideal current source. This arrow indicates the direction of current. In ideal current source, the value of current is always remains constant with respect to terminal voltage. So we are seeing the graph current versus voltage. This current always remains constant with respect to load voltage, or I can say that this value of load current it is equal to supply current. And also ideal current source, it has no internal resistance, or we can say that it has infinite ohmic internal resistance. Now if we connect the load resistance, then the voltage across the terminal it is given as Is into RL. So as we increase the value of resistances, this terminal voltage also goes on increasing. So ideal current source, it is a source which can supply any amount of voltage to the load. Now second one is practical current source. Practical current source, it is a source whose current does not remain constant with respect to load voltage. For practical current source, it has an internal resistance which is always connected in parallel to the current source. That internal resistance, it is denoted by RSH. So the load current we can calculate I equals to Is minus ISH. ISH, it is a current which is flowing through RSH, and ISH we can calculate as V upon RSH. So total load current we have calculated as Is, it is a supply current, minus V upon RSH. So in practical current source, this load current it is always less than supply current. Because of that, voltage drop across the RSH. So when we see the graph of current versus voltage, this current always goes on decreasing with respect to load voltage. So in this case, your load current and supply current are not equal. So we can revise the ideal current source and practical current source again. In ideal current source, it has no internal resistance, or we can say that it has infinite internal resistance. And in practical current source, it has the internal resistance which has some values, and it is always that internal resistance, it is always connected parallel to the current source. Now second, ideal current source supplies the constant current to the load, and here practical current source, the current supplied to the load changes with respect to voltage. In ideal current source, it can supply any amount of voltage to the load, and in practical current source, it can supply limited amount of voltage to the load. So next we have seen what do you mean by ideal voltage source and practical voltage source. Now ideal voltage source, it is a voltage source whose terminal voltage always remains constant with respect to load current. So this is the symbolic representation of ideal voltage source. This Vs represent supply voltage, plus minus indicates the polarity of the voltage, and for ideal voltage source it has no internal resistance, or we can say that it has zero internal resistance. So in this, as it has no internal resistance, the terminal voltage is always remains constant with respect to load current. So we can see the characteristics of voltage versus current. This voltage remains constant with respect to current. Now next is practical voltage source. In practical voltage source, there is an internal resistance, and that internal resistance, it is always connected in series with the voltage source. That internal resistance, as it is connected in series, so it is denoted by Rs. So Rs, it is connected in series with the Vs. Now we are to calculate the voltage across the load, that is denoted by capital V. So we can calculate as V equals to Vs minus I into Rs. I into Rs, it is a voltage drop across series resistance. Vs, it is a supply voltage, and total V, it is a voltage across the AB. So it is clear that this voltage across AB, or that voltage across load, it is always less than the supply voltage because of that voltage drop across the series resistance. So when we see the characteristics, voltage and current characteristics, we are getting that voltage, terminal voltage in practical voltage source goes on decreasing when the load current is increases. So we can revise the ideal voltage source and practical voltage source. In ideal voltage source, it has no internal resistance or it has zero internal resistance, and in practical voltage source, it has the internal resistance which is connected in series with the voltage source. Second, in ideal current source, the constant voltage across its terminal, but in practical voltage source, the voltage across its terminal changes with the current. An ideal voltage source can supply any amount of current to the load, but practical voltage source can supply limited amount of current to the load. Now this practical current sources and practical voltage source we can replace, means if the practical voltage source is given, we can convert that voltage source into practical current source, or if practical current source is given, we can convert that practical current source into practical voltage source. Now here any network is given and voltage source is given, it is a practical voltage source, that resistance it is connected in series with the voltage. Now we are to convert that practical voltage source into practical current source. In practical current source, resistance it is connected in parallel across the current source. So how we can convert? We can see one example. Here 30 volt voltage source is given having value 30 volt, and it has internal resistance of 10 ohm. Now this is the practical voltage source, we have to convert it into practical current source. In current source, the resistance is parallel. The resistance remains same, value of resistance it is 10 ohm, but it is connected parallel to the current source. Now we have to calculate the value of current source. How we can calculate? By using Ohm's law. We know that V equals to IR, so I equals to V upon R. Voltage is given 30 volt, R is 10 ohm. So from that we are get I equals to 3 ampere. So 3 ampere it is a current source, 10 ohm it is connected in parallel. So we can convert that practical voltage source into practical current source. Similarly, if practical current source is given, we can replace or we can convert that practical current source into practical voltage source. In practical voltage source, resistance it is connected in series with the voltage source. So we can see one example. Now here current source is given having 1 ampere value and internal resistance is 10 ohm. So that connected in parallel. So we can convert into practical voltage source. So the resistance remains same, that is 10 ohm, but in voltage source that is connected in series. So by using Ohm's law we can calculate the voltage, that is V equals to I into R. So I it is 1 ampere, R it is 10 ohm. So we are getting voltage at 10 volt. So voltage source it is a 10 volt source and resistance 10 ohm it is connected in series with the voltage source. So in this way we can convert practical voltage source into current source, of practical current source into practical voltage source. Thank you.